Hi there. Well, unfortunately other priorities in life are slowing down progress with this little Upshur engine, but hopefully in this video I'll be able to machine the Conrods. Now this is quite embarrassing really. Before I get on showing you the video footage, I'd done the plans for the machining process quite a while back, and for some reason I got it in my head that the big end bearing was made out of a piece of phosphor bronze, like a split rod end bush. I think that's what they call them. And I think I got it in my head because the engines of similar design that I've made have always had one of these split rod end bushes, apart from the V-twins and stuff like that. I actually started making one of these split rod end bushes and did quite a bit of video footage of it. But then I realised that it doesn't actually have a split rod end bush for the big end. The actual bush is just part of the conrod, you know, the aluminium element of that conrod, 5/16 of an inch in diameter, I think. So I won't show you any footage of me making this bush out of phosphor bronze because it's totally irrelevant. And if there is any footage that I mentioned this split rod end bush, just ignore it because it's totally wrong. Anyway, on with the video. So the conrods are made out of aluminium. So what I've done is I've cut these pieces to size, to the largest outside diameters. And these end caps, what I'm going to do is super glue them together. And then once I've done that, I'm going to go over to the mill and then drill and tap some holes to keep these end caps on. I'll do the super gluing off camera and then I'll get back to you. Now I nearly goofed up here. I nearly started centre drilling on the exact centre of this piece here. However, this end cap in reality will end up being 0.31 of an inch wide, but I've actually machined it to be let me see, 0.362 wide, because we're going to be machining some material off this side here. So what I need to make sure is that I'm drilling and tapping these holes from this back face here in by 0.195 of an inch, which is where I'm at. Apart from drilling and tapping these side holes here for the bolts, I need to drill a hole here. I think it's an oil way as well. Now these end caps need to be drilled to be 2x56 UNC clear. So what I've got in here is a 7/64 drill bit, which is about 0.1 of an inch in diameter. And the drawing suggests drilling to a depth of 0.266, which is this depth here. But I'm just going to go a little bit beyond that because obviously I've got a slight taper on this drill bit. I'm going to go to 0.29, I think. Okay, so I'll do the same on these other two holes, albeit the centre one's going to be a little bit bigger than this, I think. Well, I realised the oil hole needed to be 3/32 of an inch, so I've drilled that and just opened the end up with the centre drill. Now, I think I'll have to re-drill that again. Once I get the bush in place, I'll need to drill through the bush at some point in time. But anyway, for now it'll be okay. So now what I need to do is to tap this lower bit here, 2x56. So this is a number 50 drill bit, I think. And once I get to that point there, I'm going to drill. I'm going to go to a depth of 1/4 of an inch, and then I'll tap it. I went to 0.27 there, just be on safe side. So I'll do the tapping off camera and I'll repeat the same process on the other one. So off camera I broke the super glue and I bolted the ends back on, but I did hit a problem because on one of the ends, one of the thread stripped, so I had to do it again on this end. I think I'll get away with it because this little end here, once that's machined, it should actually get rid of these holes. So fingers crossed that'll be okay. But anyway, before I put these back on the mill to start drilling the holes for the phosphor bronze bearings, I'm going to use the mill to start machining this piece of phosphor bronze. I need a slitting saw to cut a little bit of it in half. So I've placed it on some very thin parallels, which will allow me to drill and ream right through between the parallels with this I think 5/16 of an inch reamer. So I used a wiggler to find the centre point between the vice jaws, and then I used the same wiggler to find this edge here, and then I moved it in by the appropriate amount to get on that join. So what I'm going to do is I'm going to centre drill and then drill and ream 5/16. Once I've done that, I'll move it to the appropriate point up here and drill and ream to, I think it's 1/4 of an inch for a bush to go in that end there for the little end. .6mm stub drill. .7.8mm drill bit. .5/16 reamer. So the hole for the small end is 1.875 inches from the centre of the big end. So I'm going to centre drill and then drill and ream to 1/4 of an inch, but I'll do that off camera. Well, I don't know, I totally lost the plot on that one. I just realised now, having looked at the drawing, that there isn't a split rod end bush here. This is the bush. So I've wasted my time splitting that piece of bronze. But anyway, not to worry. So what I need to do now is make a little bush to go in here. So what I'll do is I'll get a piece of bronze, machine it to that size, I'll Loctite it in place, then I'll put this back on the mill and re-drill that bush to be the right diameter, whatever that is in the drawing. But hopefully that does take a bush, I'm sure it does. Once I've done that, I'll get back to you. Well, the little end bushes seem to have turned out okay, and I've done a bit of marking up, and I think my best approach is to try and get these tapers right first of all. So I've marked the tapers up, and I'm adopting an approach that I used on previous Conrods, and I've drilled through in the appropriate places with the 1/16 of an inch drill bit. And the idea is that I'll put some drill bits in here and they'll be supported in the vise, and that will give me the correct angle to machine down to that particular taper. And for those who are following my method of madness, these are the locations here. So assuming that this is held in the vise and that way around, so turn that 90 degrees. Position 1 works out x, well, based upon the origin there, so the DRO, both x and y set to 0. Position 1, x comes in at 0.453, y at minus 0.156. Position 2, x equals 0.453, y equals plus 0.156. Position 3, x is equal to 1.805 of an inch, and position y is minus 0.229 of an inch. Position 4, x is the same, 1.805, and y is equal to plus 0.229 of an inch. So I'll go over to the mill and start cutting these tapers. So this method does tend to produce decent results. So I've got this little thin parallel on each side here. I've rested the drill bits on it. Take that out. Take the drill bits out. And now I can cut down to this level sort of fairly easily. Well, they seem to turn out okay. I mean, my radiuses aren't perfect, but I think they'll be alright. And this is getting to the tricky bit now, because these need to be machined to various sort of like widths and levels. And the centre of the big end is offset from this plane here to the little end. So the little end centres up here and the big end centres down here. But I think what I'm going to do first of all is machine the bosses on here. That's probably a good starting point. So first of all, centre the rotary table. 0 the x and y coordinates. Well, if you've seen some of my previous videos, you might have seen this setup before. So this is a 2 Morse taper, blank, which has been machined. It's threaded in the centre. There's a little thread there as well. Now the height of that has been machined to be exactly the height of this 1, 2, 3 block. So this 1, 2, 3 block will be bolted to the table. I've machined a mandrel here which will fit through like that. I need to loosen those off. That will be bolted down like that. And then I can machine the boss on this side. Now this, as I mentioned before, these bolts here are slightly offset. So it's thicker on this side than that side, and this is where the boss needs to be made. So I'll set it up and then I'll get back to you. Okay, I think this is all set up correctly. This is a 12mm
4 flute end mill, and I moved it, or the table, this way 6mm to get the edge on centre, and the radius of this needs to be 0.276. So I've moved the y-axis again by 0.276 of an inch. Needs to go to a depth of 109 thou. And I've just done a little test cut just to make sure that the radiuses look okay, and they do. So we'll carry on now, and I'll be turning the table that way, clockwise. So move the cutter down. I'm going to go fairly steady, 10th thou at a time, no rush. Everything's bolted down. So I'll just carry on to a depth of 109 thou, then I'll get back to you. Seems to have turned out okay. And the radius, just checking, should be 552. Oh, 554. Pretty happy with that. Well, they've turned out pretty good. And while I'd got the setup on the rotary table, I took some material off here. That was 81 thou to come off from this top edge here, and at some later stage these are going to be reduced down to 29 thou from this face here, so there'll be about 52 thou to come off these. But for the moment, I think what I'm going to do now is go back to the rotary table and turn these ends here. Okay, so it's a similar setup as before. I've turned down this mandrel, fits through the small end. I've used some old slip gauges here just to raise it off the face. I've got a 5mm end mill in there so I can get close into the corners, and it's just a matter of giving it a go. And take it nice and steady. Well, they seem to have worked out okay. Just gone in a little bit there and there. At least they're a mirror image of each other. I don't think that'll matter. So what I need to do now is to machine round here to create like a boss, and I need to machine down to the same depth as that. Likewise on the other side, machine round here to the same depth as that. And I've purposefully not taken any material off these sides yet. That'll be the last process, because leaving it like this sort of really helps in terms of work holding. So I need to machine 109 thou off this. So that seemed to work out okay. Fingers crossed I've got it to the right depth. So I need to switch it round now and repeat the same process on the other side, but just take 81 thou off it. But I'll do that bit off camera. This seems to have worked out okay. So what I need to do now is to clamp these on the milling table like that, and then machine this bit off here so it's level with these areas. Straightforward as that, so I'll do that bit off camera. Well, so far so good. The target width of these is around about, well, 172 thou. I think this is about 168, and this one's 173, so I'm happy with that. So all I need to do now is to machine off this top left 60 thou, and the bottom right boss I need to remove 52 thou. So I've just put a slip gauge under here and then bolted it down, and it's just a matter of taking 52 thou off there. Double check, 52 thou. 10th thou at a time, nice and steady. It's 60 thou to come off this end. Well, that seems to turn out okay. One thing I've done all along is I've made sure that these end caps have stayed on, and I've put some little witness marks on just to make sure that I don't get them mixed up. But I think they've turned out alright. Well, I just couldn't resist the temptation to do a little trial assembly. And the cam gear will fit in there, I think. And they look pretty central. So, really happy with the result.
Well, I think these must be the most complicated Conrods I've ever made, and I think it's because the big end and the small end, the centres are offset. So that introduces a bit more, you know, of a complexity really. But I think they turned out okay in the end. Now hopefully my next video will be looking at the piston. So that should see the bottom end fairly complete. Apologies for the delays in getting these videos out now, but like I say, there are other priorities in life at the moment. Anyway, I hope you enjoyed this video, and I do hope to see you later.